Okay, ladies and gents, let's work on this parabola equation where we have the x-intercept. So we are given the x-intercept, this point and that point, and we are required to find the equation of this graph. We have the x-intercept of f at x. So when you have the x-intercept, the formula that you need to use is y is equals to a into x minus x1 into x minus x2. So we just have to name our point. This might be my x1, y1. So I'm going to call this my x1, y1. And I'm going to call this point my x2, y2. Then now we can just do the substitution. Y is equals to a x minus my x1 is negative, so I need to subtract it and put it inside the bracket so that the negatives can cancel. So my x2 is just 1, so this will be x minus that 1. Now I have the bracket minus into minus 5. I need to work that out, and this will give us x plus 5. The other side is just x minus 1. So when you are given the x-intercept, they will give you most of the time the y-intercept. Now we need to substitute any other point on the graph to find the value of a. So this thing passed through the point 0 and 15. So if it passed through the point 0 and 15, what is my x? It's 0. And what is my y? Is just 15. So meaning that where there's x, we need to put 0. Where there's y, we need to put 15. So 15 is equals to a into 0 plus 5 into 0 minus 1. This is what we have so far. We need to solve the value of a. This is just 5, and it will be multiplied by 1, which will give us minus 5a. It's equals to 15. Divide both sides by minus 5. Divide both sides by minus 5. Therefore, what is the value of a equals to? Minus 5 goes into 15 3 times, but the answer is negative 3. That's the value of a. So now when you have the value of a, you need to substitute. You need to sub in that a is equals to minus 3 in this equation, the simplified equation. Don't substitute on that equation because you still have to simplify the minus into minus 5. So the equation that we need to substitute in is that one. So let's quickly work on that. We're going to say y is equals to, where there's a, we can put minus 3 inside the bracket. This is just x plus 5, close the bracket, x minus 1. So now we can use the FOIL method to multiply out our brackets. So I'll have this as x squared minus x plus 5x, which will give us positive 4x. 5 times minus 1 is just minus 5. So please make sure that you pause the lesson, you multiply out the brackets using the FOIL method, and you should get the same answer. So now if we multiply out the bracket, what will be the equation of that? The equation, it will be minus 3x squared minus 3 times 4, which will give us minus 12x, minus 3 times 5 is just positive 15. And this is your answer. So we've managed to find the equation of this graph in the form of quadratic, form. Right, so now let's answer the following questions. We're going to use this equation. I'm just going to rewrite my equation down, then we'll try to answer the following questions that we can expect to get from exam. Okay, so remember, we have our y to be equal to negative 3x squared minus 12x plus 15. So this equation is in the form of y is equal to ax squared plus bx plus c. What is the value of a? The value of A is minus 3, the value of B is 12, and the value of C is 15. Let's try to find the coordinates of D. Let's say D is the turning point. So the coordinates of D, let's say they want you to find TP, stands for turning point. So to find the turning point, first thing first, you will have to find the x coordinates of the turning point, and the formula that we use to find the x coordinate of your TP, your turning point, the formula that you use, you're going to say x is equals to minus b over 2a. That's why it's very important to understand that when it is in this form, what is the value of a, what is the value of b, and what is the value of c. So I'm just going to substitute what I have on that equation, because already I know that b is minus 12. So this will be minus inside the bracket minus 12, everything divided by 2 into the value of a, which is minus 3. This is just 12 over minus 6. So it's 12 over minus 6, which will give us negative 2. Please pay attention. The x coordinates of the turning point, x is equal to negative 2. So how can we find the corresponding y value? How can we find the corresponding y value for our turning point? We now substitute this value here, the x is equal to minus 2, into your equation. Which one? That equation, the one that we just calculated. So y will be equals to minus 3, where there's x, we need to put minus 2 squared, minus 12 into minus 2 plus 15. Therefore, when you punch that on the calculator, you just have to punch it on the calculator. We get our y to be 27. Please pause the lesson, try to work this thing out first. And then now we have our TP as what? Our TP, the turning point will be minus 2 and 27. Those will be the coordinates of that point D. Yes. So now we can find the equation of the axis of symmetry. Let's rewrite this down. Remember, we still have our equation to be y is equals to minus 3x squared minus 12x plus 15. So let's say the equation is given like this. What will be my axis of symmetry? What will be the equation of axis of symmetry? Remember that the axis of symmetry is the line that divides the graph into two equal parts. So look at this. What I'm going to do from this, I know that the axis of symmetry is the x coordinate of what? Is the x coordinate of your TP, your turning point. And we said we calculate that by saying minus b over 2a. We already did this and we got our x to be negative 2. So that negative 2 is the axis of symmetry. Is the axis of symmetry. And the formula to use to find the axis of symmetry, you need to use that formula. This is easy. The x coordinate of your TP. So on this graph, what will be the domain and what will be the range? We need to find the domain and the range. Okay, so the domain, first thing first, you check. Let's start with the range. Let me explain the range first. The range, we check the value of a. Remember, this is in the form of ax squared plus bx plus c. So the value of a is negative. So this is negative. It's less than 0. Your graph will be concave down. So when you find the range will be y must be less than or equals to y must be or less than or equals to the y coordinate of your TP. So remember, we had our turning point as -2 and what? -2 and 27. Was it positive 27? Yes, we got this as 27. That was our turning point. So this is in the form of P is to Q. If our equation, remember our equation, we can write it in the form of AX minus P squared plus Q. So when we find the range, y must be less than or equals to the value of Q, which is this Q. What are we referring to? This Q is your y coordinate of TP. So now remember, the y coordinate of TP is just 27. So the range of this graph will be y must be less than or equals to 27. Like someone might prefer to write it using like this and say y must be an element of, so this will take from -infinity all the way to positive 27. But the 27 is included. But remember, y must be an element of real numbers. That is the range. Right. So the domain of the quadratic equation, it's always x must be an element of real numbers. X must be an element of real numbers. Okay. Let's bring back our equation. Let's rewrite our equation on the board so that we can be able to answer the following questions. Let's first bring back that graph. Remember, our graph looked like this, and then we had the value of D there, which was -2 and 27. We had, this is my x-intercept, which was 1 and 0. And then we had another one which was -5 and 0. So let's say from this graph we need to answer for which values, number one, question number one, for which values of x, for which values of x it's our f at x greater than 0, and for which values of x is f at x less than 0. So let's try and answer this question. This is how I'm going to answer the questions. First thing first, they are asking you where it's f at x positive. So when I say, for number one, when I say f at x greater than 0, I'm asking you, remember this is your x-axis, this line here, it's your x-axis. We are asking where is the graph above x-axis. So it's above x-axis. Let's highlight where is the graph above. From this point going up, all up to that point. So the graph is above. So it's above between 1 and what? And -5. So the answer will be x must be less than, okay, let's not say less than or equal to, because they said where is this greater than 0. So x must be less than 1 and x must be greater than what? That -5. So this is your answer for where is this graph above the x-axis. Right. So another notation that you can use, you can say x is an element of, you start by writing a small number which is 5, and then you write the bigger number which is 1. That's how we answer the first one. The second one, the second question, where it's f at x, where it's f at x below. This one is asking where is the graph below the x-axis? So look at this. Where is this graph below? Okay, it's below from this point going down there, and from this point going down there. So our graph is less than 0 from this point going that direction, and from this point going that direction. So x, to answer this, x must be greater than that 1, x must be greater than 1, or it must be less than -5. So x must be less than -5. And another notation that we can use, someone can prefer to say x must be an element of, we always start with the small one, so we're going to start from -infinity because it is approaching what? -infinity. So it will be from -infinity to that -5, then union from 1 all the way to +infinity, because this side it will approach the +infinity. I hope this makes sense. And that's it. That's how you answer questions on parabola, where we have the x-intercept. We first started by calculating the equation of the graph, and then we calculated the turning point and also the axis of symmetry of this graph. So the axis of symmetry is the x value of your turning point. So this tells you that your axis of symmetry is x is equal to -2. And that's it for the lesson. Please make sure that you hit the like button and subscribe so that you don't miss our next lesson.